This video is just an attempt to get you started with thinking a bit more probabilistically about questions in epistemology more generally. You might be the kind of person who's very comfortable with probability, and this might be completely elementary. This video is more intended for the kind of student who, you know how to calculate the probability that you'll get a 7 if you roll 2 dice and add up the result. But you're not very comfortable with terms like Bayes' rule. You haven't come across the idea of scoring a probabilistic prediction for accuracy, or you just feel like maybe there's a bit more going on in this area than you're completely across. You don't need to become an expert for what I'm going to cover in the rest of this topic, but there's some basic introductions that I hope will orient you and make you not feel too nervous about these ideas. So one common thread that's going to be running through the readings is that a good epistemic agent is somebody, they follow probabilistic rules. This is an important contrast from an earlier way of thinking about epistemology, where it's about, well, it's what do I believe? And belief is on or off. But if you need to be updating probabilities, it seems you're doing something that's more graduated, right? And one of the key ideas is we're working with the notion that instead of having outright belief and disbelief, you have a degree of confidence in each proposition that you're wondering about. Sometimes these are called credences. That's a pretty handy word because it sort of marks it out as a bit technical and a bit different from belief. But sometimes I might just say, your belief is 0.6 that it's going to rain tomorrow. And that was the same thing as saying you have a degree of confidence that that could be described as 0.6 that's going to rain tomorrow, or you have a credence of 0.6 that's going to rain tomorrow. And there's a subtle debate about whether that's the same thing as you outright believe that the chance is 0.6 that it's going to rain. We don't need to worry about that. We can ignore that subtlety. So this is one thing that's going to be going on. Now, immediately that raises a question. Okay, well, what is the measure of success when it comes to a credence, right? Because with a belief, success is the belief is true, failure is the belief is false. But when credences come in degrees, what does it mean for us to have succeeded or failed with one of our credences? Consider this, for instance. The Weather Bureau says to you, the chance of rain tomorrow equals 0. Let's say they're quite pessimistic. They think it's almost certainly going to rain. And so you adopt your credence, you just trust what they say. Your credence becomes 0.9 in the proposition, it will rain tomorrow. And it doesn't rain. And your friend says, the Weather Bureau got it wrong again. You might say, really? They didn't say it would rain. They just said, probably, and that's consistent with it not raining. So, is there really any such thing as getting it wrong? In one hand, you're right. They didn't say definitely it will rain, so you can't say what they said was false. But on the other hand, we do want to say that in a way, it looks like their prediction is not very well calibrated with what actually happened. If there were another Weather Bureau that gave a different prediction, and let's say the other Weather Bureau said there's only a 20% chance of rain tomorrow, there's a sense in which we want to say this Weather Bureau seems to have done better on this occasion than this one. So the first thing I'd like you to think about is, how can we score these probabilistic guesses as being better or worse when they don't fit the normal criterion of truth or falsity. There are some well-defined mathematical rules for this, but just trying to think about it in the general is probably a good exercise for you to start with. Okay. Second thing to talk about is the idea of, let's see if I can get this, there we go, the idea of a Bayesian agent. You'll see this phrase in some of our readings, and relatedly, you'll see the word prior and posterior, and both of those are being used in a technical sense that you need to be aware of. Okay. So, first, if you don't know what Bayes' theorem is, also known as Bayes' rule, I should have an apostrophe there because it was the theorem of Thomas Bayes, or the rule of Thomas Bayes. If you don't know what that is, it is related to this idea of a Bayesian agent, but you don't need to know the full details of this in order to get the gist of this. So don't stress over Bayes' theorem just yet, okay? You can happily forget about that for now. I do recommend for your overall mental health that you know what Bayes' rule is, but you don't need to know about it right now. Okay. So let's be specific about what a Bayesian agent is. Remember, this is going to be in the context of trying to develop a well-described mathematical set of propositions to describe a group of epistemic agents who are trying to know stuff and find things out about the world. So it's always going to be, in some sense, an idealization or a simplification. Right? We're not really worried about whether you, in fact, are a Bayesian agent. It's not the sort of concept you would typically apply to real people in the real world. It's more a concept you would apply to an ideal agent in a mathematical model. So with that little disclaimer at the beginning, a Bayesian agent basically always starts out with some initial credence. Right? They start out with for every proposition they might have an opinion about, they have a credence. You might see this written down as CRP, which means the credence of that agent in the proposition P. So the proposition P could be, it will rain tomorrow, or that St Kilda will win the grand final, or whatever. So let's say St Kilda wins 2021 grand final. And the Bayesian agent will have some credence. Right? In this case, this is an agent that is very confident that St Kilda will not win the grand final. What if I put in there, just for illustration, something even more extreme? Because I don't know anything about the football at the moment, so I have no idea even if St Kilda could win the grand final. But what about the proposition that Toby is a human being? This is one that I'm very confident of. So let's get that credence a bit higher. Let's say maybe it's 9, 9, 9, 9, 9. Let's put an 8 on there just for variety. Now you might wonder, couldn't we say, because I'm so sure of this, couldn't we say it's credence of 1? Well, an important thing to keep in mind here is, if you put in a value of 1, then effectively you're saying this is a proposition the agent can never change its mind about. No evidence could persuade it otherwise. And it's hard to imagine evidence that would persuade me otherwise, but what if I had an experience like in a film like The Matrix or The Truman Show that really threw off my fundamental assumptions about what sort of person I was and where I was? Maybe I could be persuaded I'm actually a member of some alien species and I just dreamed the existence of human beings and the planet Earth. It's a very long, detailed dream, I can tell you, but turns out it was just a dream, right? So for that sort of reason, you can't set the credence for these sorts of propositions to be 1. Otherwise, it'd be like I'd be dogmatically wedded to that fact that I'm a human being, even though in practice I'm probably never going to have reason to doubt it. Okay, so that's just an illustration of a prior. Why? And so that's the concept of a credence that you start out with. But then these agents, they will interact with the world. They will get evidence of some sort. The evidence could be from a personal experiment they carry out, or it could be from talking to another agent. And what happens then is they change their credences. They go from their prior belief to a new belief, the posterior belief. And that's really all that these terms are getting at for the most part, is the idea that their beliefs are undergoing change, credences are undergoing change, and that's what learning is in these models. What makes the agent Bayesian, though, crucially, is that this process is governed by Bayes' theorem, also known as Bayes' rule. You can go and watch other videos on YouTube if you want to know what Bayes' rule is, but for our purposes, I just want to emphasize a couple of things about Bayes' rule. One, it's kind of ideally rational in a sense. It is determined, it follows from the calculus of probability, right? So from pure math, you get Bayes' rule. It's not some new discovery outside of probability theory. It's just straight probability theory. It's just a very handy way of representing probability theory. And so, in a sense, all rational agents should follow Bayes' rule. But on the other hand, it can be very sort of computationally expensive, we'd call it, right? Hard to calculate. Because it's ideally rational, it takes into account every possible scenario that could bear on things. And in practice, that's going to get really hard, especially if you're using a model that has a complicated social network where, blogs might be telling me that it's going to rain tomorrow because of what Smith said, but blogs also could be doing it for a completely different reason, and Smith said the opposite. How do I take those two possibilities into account? But there's not just those two possibilities, because each of Smith and Bloggs' cousin Jenkins are themselves in contact with 20 other people in the network, and there's all these different patterns that could have led them to say what they're going to say. So basically, it can rapidly become computationally intractable, impossible for us in a normal time span to calculate this. And so you'll sometimes see the phrase heuristic used to refer to the way people actually work things out. And heuristics are contrasted with following Bayes' rule. They are shortcuts that will often give you very good answers, perfectly respectable answers, but not strictly ideally rational ones, right, that follow truly to the full probability calculus. But as I say, the full probability calculus can be just impossible for normal finite creatures like us to calculate. They can be even impossible for us to calculate using very powerful computers with a lot of time and energy. So that's already introduced you to one way in which an agent could fail to be Bayesian, right? In most of the sorts of models we're going to be looking at, they'll fail to be Bayesian because they use a heuristic rather than updating strictly in accord with Bayes' rule. The other sort of more fundamental possibility is they might just fail outright to have credences, right? So you could have a model where you say, my agents in my model don't have graded degrees of belief. They just believe or disbelieve, right? Two attitudes they can take towards any proposition P. They either believe it or they disbelieve it. You could get slightly more complicated without going to full credences and say, well, what about undecided? I might have the attitude of I outright believe P, or I disbelieve P, or I'm undecided about it. Right? So I believe I am human. I disbelieve that St Kilda is going to win the grand final. I'm undecided as to whether there is an infinite number of prime numbers. I really don't know what the evidence is on that, so I just haven't really thought about it. Haven't come to an opinion. That's one a sort of more fundamental way in which an agent could fail to be Bayesian, and that's also going to be useful for some sorts of models where you need to capture particularly simple kind of epistemic agency. That'll do for this introduction. So remember, have a think about how would you score probabilistic predictions, and if you've got a taste for what a Bayesian agent is and you're curious to learn more, go and watch some videos on YouTube about Bayes' rule or Bayes' theorem so you can understand what that is.